everyone. This lesson we're going to look at sections 10F, G, and H in your textbook. In 10F, we're going to look at how we can calculate arc length based on some attributes in a circle. So in a circle, if you look at this diagram here, we can characterize a circle using its radius. And if you mark off a little section in the circle, the smaller piece is called the minor sector, and the angle contained in this minor sector is theta. The arc length that subtends this minor sector is L, as compared to the rest of the circle, which is the major sector. In order to calculate the arc length, you can actually form some proportions. We can compare the arc length, L, to the entire length of the circumference, and then equal this to the angle subtended by the minor sector, which is theta, compared to the angle that corresponds to the entire circle in one rotation, which is 2 pi. In symbol form, arc length is L, circumference is 2 pi r, and this is equal to theta over 2 pi. If we rearrange this formula, you can see that the 2 pi and 2 pi will cancel out, and arc length will equal to r times theta. Be careful when you use this notation, since we derived this formula based on 2 pi as being the angle of one revolution. Your angle theta must be measured in radians. Next, we can also look at the area of a sector. So if I call the area of the minor sector A in the same circle, using a very similar approach, we can compare the area of the minor sector to the area of the entire circle, and compare this to the angle subtended by this minor sector theta to the angle in one revolution, 2 pi. So area of the minor sector A is over pi r squared. For the area of a circle, you have theta over 2 pi. If you rearrange this equation, you will get area equals 1/2 r squared theta, right? Because of cross multiplying and also canceling out the pi's. Once again, this is derived using 2 pi as the angle going around the circle once. Angle theta must be measured in radians. So we're going to look at a few examples that apply these two new formulas on the next page. So here you've got a very interesting diagram and some information given. So technically, you have two very large arcs. DFE is the smaller one with the inner radius of 4 centimeters, so from here to E. And also you have the larger arc, which is ACB. The outer radius of this shape is 9 centimeters. So extending from the center to B, which means that the difference in the radius will give you the length of BE or AD. We're going to look for the area of the yellow part and also the perimeter of the shaded region, this yellow part here. So let's start with the area. Well, the area of this shape can be calculated using the arc or area of a sector equation or formula. We can say that the larger arc has area of A1, smaller arc has area A2. So the total area will be calculated using this word equation. And then now we're going to apply the formula. Well, how can we calculate the area of the outer sector? It is 1/2 r squared times theta. If the smaller angle, or the angle of the minor sector, is pi over 6, then this larger angle on the other side would be 2 pi minus pi over 6 or 11 pi over 6. So let's substitute. The outer sector can be calculated using half 9 squared times 11 pi over 6. The inner sector can be calculated using half 4 squared 11 pi over 6. And so you can simplify this expression. 11 pi over 6 is a common factor. Technically, you have 81 over 2 minus 16 over 2. That gives you 65 over 2 times 11 pi over 6. And simplifying this will give you 715 pi over 12. In the next part, we're going to calculate the perimeter of this shape. So the perimeter of this shaded region will contain the arc length from A to B, so we call this arc ACB. It should also include arc DFE, the inner arc, plus don't forget the endings BE as well as side DA or AD. So here is the plan, the two arcs plus the two little segments at the ends. So to calculate the perimeter or arc length, we're going to use radius times angle. So for arc ACB, radius is 9, the angle is 11 pi over 6. Arc DFE, radius is 4, angle is 11 pi over 6, plus 2 times 5, because that's the difference of 9 minus 4, the outer radius minus the inner radius. So simplify this work. You have 13 over 6 times 11 pi plus 10, or you can write this using a common denominator of 6, so the answer will be 143 pi plus 60 over 6 centimeters. Okay, so we have found the area and perimeter of this funny shape. Next, we're going to look at another application of calculating arc length and area of a sector. So in this question, you're told that a wire of length 20 centimeters is bent to form a sector. If the area of the sector is 25 square centimeters, find the radius. So here's a schematic drawing. Please note that the dotted line is not part of the wire used. So your 20 centimeters is made up of basically A, O, O, B, and also arc BA. So what we know then is that we have 2 radii plus the arc length equaling 20 centimeters. I'm going to rearrange this equation to get L equals 20 minus 2R and name this equation 1. Another relation that we can relate to is the area of the sector, because we are given 25 square centimeters as the area. So knowing that area of a sector is half r squared theta, by plugging in 25 into area, I can try to isolate for theta, which gives you 50 over r squared. I will call this equation 2. It seems like we're stuck here, but don't forget we can also calculate arc length using L, r the radius, and also theta the angle. So if I try to pull out that formula, L equals r theta, we can actually form a third relation if I substitute equations 1 and 2. So sub in 20 minus 2r as L, and sub in 50 over r squared as theta. This way, you can eliminate L and theta, the two other variables, and have a relation simply involving r the radius. Simplify r and r squared, you get 50 over r, multiply every single term by r to get rid of the rational expression or fraction. You will actually end up with a very nice quadratic equation. And this trinomial can actually be factored, and this will give you the radius equaling 5. And this is the radius that you're looking for. Next, we're going to look at the last example in this lesson. Find the perimeter and area of the segment. So before we proceed, let's talk about two new terminologies. In this diagram, you can see a red line connecting 2 points found on the circumference of the circle A and B, but this line doesn't pass through the center O. Any line that connects 2 points on the circumference but does not pass through the center of a circle is called a chord. And the area marked off by the chord and the circumference is called the segment. So we are looking for the perimeter and area of the segment in this case. Well, for the area of the segment, you can think of this as part of the area of the sector formed between O, A, and B. And once you can find the area of this sector, you have to subtract the area of the triangle, and this way you'll be able to calculate the area of the segment. So we do have formulas to calculate area of a sector and also area of a triangle if it's a SAS triangle. So the area of the sector is half theta times r squared, and the area of the triangle is half side A, side B times sine of AOB, which is the 2.4 radians here. So once you realize this becomes a substitution problem. So plug in angle 2.4 radians, 2 for radius, simplify, you will get 3.45 square centimeters. As for the perimeter, it's even easier. The perimeter of the segment, you need to know the length, the arc length between A and B, and also the length of AB. Once again, because triangle AOB is an SAS triangle, you got it. You need to use the cosine law to find the opposite side from angle 2.4 radians. So the perimeter will be arc length plus AB. Arc length is radius times angle, and side AB would be side A squared, side B squared added together, minus 2AB cosine AOB. Plug in your numbers and very carefully, and make sure your calculator is in radian mode. Simplify this expression, and you will get 8.53 centimeters, correct to 3 significant figures. Okay, so this is the end of your lesson. You will have time to work on your homework questions. Tomorrow, I will be back to address any issues, questions. We'll take up homework questions that you didn't get, and then you will also get an extra review period. So don't worry about the blue stuff. Okay, bye for now.